question. So the question was, how does locking, or how does this affect locking in MongoDB? So the answer is that in Mongo, there's read locks and there's write locks. So read locks, the aggregation framework queries take a read lock, and read locks in Mongo, you can run as many read queries as you want, and they all run in parallel. So write locks have to stop other writes against the same database. So since this doesn't require any writing of data, it doesn't have to take out any write lock. So it's purely a read operation, and it's treated basically the same way as a regular query is as far as locking goes. So you can run aggregation queries alongside regular queries or multiple aggregations, and they'll all run in parallel. Does that answer your question?
Yeah, just was wondering though, I mean, how would it affect, like, would it not affect this intrinsic garbage collection? Because you're doing those read queries and still caching all of that data for aggregate functions with the read locks, and would it be a problem? I mean, you couldn't scale data, am I right? That's not it, right?
I mean, there's some memory overhead in doing the aggregation, depending on what exactly you're doing and how much data you have coming into the aggregation. But there's no notion of like garbage collecting or caching. It's basically just taking your query, executing the query, feeding the data into the pipeline, and executing it.
Thank you.
Mm-hmm. Yep.
Hi. So you said that MongoDB is not really optimized for joins. So we'd always have flattened or like unnormalized kind of data. So consider a scenario that we have 2 time series columns which are trillion rows, and then you have 100 columns, static columns, which are just like 10 rows. So the way to store the data would be to store the 100 columns for each of the trillion records, making the size of the database 100 times more. So is this the only way we can do it, or is there a way around it?
So sorry, say that again. You had one table which is a trillion rows?
Trillion rows, but 2 columns. So there are 2 columns, which are time series columns, and there are trillion rows. And there is a table which has 100 static columns, but only 10 rows. So in order to store it in this format, you need to store the 100 columns trillion times in order to run a query on this, right? Thereby making the size of the database 100 times more.
So what's the relationship between each row from the trillion?
They relate to like each row could belong to any 10 of these static rows.
Oh, I see. So in that case, you would what you would do most likely. I mean, there's different ways you could do it, but each of those rows in the bigger table, you could store an attribute that is some kind of reference to the static table. And since you can create an index, you create a field in your larger table. Let's call it table A. Table A has a field that references some field in table B, and you create an index in that field. So by querying on table A, you have a field that gives you a direct reference to a row in table B. Does that make sense?
So is it like join only, right? Primary key and like foreign key kind of?
Yeah. So in that case, it's not, the server is not doing the join for you, but so you would basically do 2 round trip queries on the client side. But since you created the index, it should be relatively fast. The only difference is the server isn't doing the join for you.
Oh, so we have to write 2 queries instead of writing 1 query with the join.
Yeah.
Okay. So, but how does this aggregation compare against other columnar in-memory databases like Vertica or Parallel? Does it perform similarly in cases, or do you have done any benchmarking?
We haven't done any benchmarking. I think there's no right answer to that because every use case is different. Every hardware is different. There's so many factors that it's hard to get an apples to apples comparison.
For the kind of use case that I just described, for that use case, any?
Yeah, there's no good answer for that. Sorry. All right, sorry.
Yeah, help me understand the technology. Like, if you have 100 clusters, a cluster of 100 different servers, I have 1 billion rows out the thing. How does it know where to go get the data? I know it's shared nothing architect how it works, but if you have 1 billion rows, 100 servers, and you start aggregating, is each server reading the same amount of data, or does it know entry points into the data that it says, okay, this server is going to handle the first 100 million rows, this server handles the second million rows, and is there a consolidation join everything together?
Okay, so this question was how, I'm going to sort of paraphrase that. How, if you have a really huge data set that's split across multiple machines, how do you use this aggregation to coordinate aggregating all that data across multiple machines? Okay, so that's a good question. So in Mongo, with really large data sets, it's handled by something called sharding. So sharding is, in Mongo, handled by running multiple instances of Mongo, and each instance of Mongo has a portion of the overall data set, and your application interfaces with the data by communicating with Mongo. It's called the Mongo S process, and the Mongo S process acts like a router. So if you send your query to Mongo S knows which shards your data, the data that you're querying for lives on, so it routes that query to the correct shard. So in cases like this, where you have an aggregation that might need data that lives on multiple shards at once, what it does is it will send your aggregation command to all the shards, and all the shards will run the aggregation on just their own portion of the data set up until it hits the first group operator in the pipeline. So it applies things like indexes and matches and filters and skips and lords and all that stuff to the pipeline input, sends it back to the Mongo S, and the Mongo S takes the results from all the shards and merges them together and executes the rest of the pipeline operation. So in that case, it sort of appears seamless to your application that the aggregation is actually happening on lots of servers at once, but the end result is basically the same.
So the indexes are not on the individual clusters?
Sorry, say that again?
You said where are the indexes then?
The indexes are always built on the individual Mongo instance, so each individual shard in that case.
So it's like a name node kind of thing where you have the data dictionary stored on the master node, like kind of a thing, and it's sending the processes?
Yeah, so I mean, you could, an analogy with Hadoop would be like Mongo S is like the name node, basically, and the data nodes are like the shards.
Zookeeper, you mean, right?
Or Zookeeper, but I was talking about Hadoop specifically.
Just one follow-up to that question. The big data, like I think of big data and I say, I don't have to shard, right? That's what HBase's premise is, or I would think that if I'm sharding, like it puts in all these headaches for me. I mean, yeah, it's a great solution. You guys are doing fantastic. You know, I really mean it. But really looking at it, it's like if I'm running a business, I still have to worry about shard replication. What if disaster recovery? I mean, do you see this as a problem at some point in time?
Yeah, I mean, Mongo is basically, I hate to sound like salesy, but Mongo is sort of built with all these headaches in mind. So things like replication and sharding, it's built in such a way that it tries to minimize the setup and the cost of operations for managing things like that. So setting up a replica set and having your data be redundant is designed to be very quick and easy. Sharding is designed to be as quick and easy as possible. So, I mean, it's designed with those headaches in mind, basically.
So does it keep 3 copies of the thing on instance?
If you use replication, it keeps as many copies as many replicas that you set up. Yeah.
Is there a dialogue between Mongo and other NoSQL organizations if you want to extend the syntax or the operators? Is there any kind of uniformity that's emerging as we go forward on this thing?
His question was, is there any kind of uniformity in standards? I mean, there's no standard. It's an open source project, so anybody is welcome to file a ticket or file a feature request or vote on it. And we take into account the community feedback. So features that people really want and they ask for and they vote for, we try to give it to them. And that's one of the reasons that the aggregation framework exists in the first place.
So do you see things that other NoSQL organizations or entities are doing? You say, yeah, we should do that too? Do they see that in you?
Probably. I'm probably not the right person to answer that question, being more of a technical background, but sure, I think so.
Actually, I have a follow-up question on that, because the first presentation by Edith was actually talking a lot of database, like graph database, one of the NoSQL, and then the concept of thin row and the wide row. So all of those, I understand it falls within NoSQL. So, but when you present the MongoDB, I was thinking if MongoDB could do like graph database, or it could do thin row or wide row as what's presented earlier as NoSQL database could do, or you can't.
I mean, things like the graph database, like Mongo's not built to do graph data. I mean, you could model a graph in Mongo, certainly, but it doesn't have features like graph traversal built into the querying engine. And things like storing, wide columns of data, it's just simply not designed to store that. I mean, you could certainly build the same application, but it would be designed differently. So you would design it so, each document is one element in the column, for example, that has some key.
Yeah, can I just add the last question? I think what you're looking for is something equivalent to like ANSI 92 standards, which is like, if you know that, you can write SQL against pretty much any database. And with this, it's just so in its infancy state, that just doesn't exist yet. And all of these, unfortunately, a lot of the products are just, it's open source, it's readily available, and you can look at it, but there really is no standards across the board yet. And not only is there no standards within each architecture of NoSQL, but the different architectures of NoSQL, whether it's document-based or columnar-based or graph-based, they're all completely different. Like learning them would be like learning a completely different, it's like going from COBOL to object-oriented. It's something that you have to just get your head around and just start thinking differently about your data. The other thing to add also is that, whether it's a wide row or a skinny row, what Elliot was trying to explain is that the concept of being a good data modeler doesn't go away, right? And I think, Mike said it a few times, depending on the usage patterns, you want to architect your data a certain way. What's really great about this stuff is you can ingest this data in any format, right? If they create rows or if they create columns or the arrays get bigger, they create new labels in the website, you can ingest this stuff very, very easily. But when you're modeling your data for extraction, there is still a process and best practices for modeling your data depending on the usage patterns. That's a good question.
Yeah, go ahead.
Do you notice an IDE that give you IntelliSense specific to the syntax on MongoDB? Like SQL Server Studio, right? You can, as you type, they have IntelliSense to your object models and the functionality. I really would like to something like that.
The question was, is there some kind of IDE that has like an IntelliSense type feature for Mongo? There's a lot of IDE, I wouldn't call them IDEs, like graphical interfaces, like graphical shells for Mongo, but I haven't really used, so I'm not sure if they, I'm guessing that some of them...
WebStorm is probably the best.
WebStorm? Okay. So yeah, there's one.
Thank you.
Yeah, there's a bunch of different Mongo shells that are third-party that Tenjin doesn't build, but have a lot of useful features like that, so there's probably something.
What are the top revenue generating applications for this data analytics?
Top revenue generating applications for this? I don't know, that's your job. If I knew them, I wouldn't tell you. Yeah, in the back.
Yeah, I've got a pair of implementation questions for Elliot. that project that you showed us earlier, my firm tried to create some similar prototype with Storm and Cassandra that set up.
Yeah.
So two specific problems that we ran into was with Storm, we figured out